Okay, so I think this is everyone, so we'll get started. If you tuned into last week's webinar on Machine Editor, you'll have been introduced to layers. Every machinable object in CabMaster works on layers. It's worth noting that you need CabMaster with Machining Premium to be able to view and output machining. Today I'm working in CabMaster Pro version 11.1.0.121, which is as of now the latest version available. I'm also going to be using EzyNest 23, which is the latest version. If you're using NRoute, nearly everything's going to look the same. Some buttons might have different names, and it will be purple instead of red. Just some quick housekeeping. If you have any questions, you can type them into the bottom of the Q&A tab on the left-hand side of the webinar screen. We have Aaron and Jamie here to answer those for you as we go. Any questions that we think would be helpful to share with the group, I'll go back at the end and we'll answer those. If I don't answer your question at the end because it's something more advanced that we haven't looked at all, there probably will be another webinar on a more advanced machining for EzyNest. I am going to keep this simple. It's very easy to make it overcomplicated. I'm going to try and focus on what 99% of users want to know for intermediate day-to-day use. I'm going to start with the floor one door. There's two ways to view machining, two easy ways to view machining. The first one, if we go to Cabinet Machining, click on View, tick the box, and then we can select our parts from that drop-down list. Alternatively, we can go to the bottom right corner, click that little arrow, and at the top of our list, we can go to Machining. Now, instead of selecting your parts from here, you can also select them from here. We're going to view the back, which I will do there. And I'm going to click on the red line. So the red line is our border. We can see down here, it shows layer equals border. It also shows our dimensions. So the corner of that is 0, 0. That's showing that that edge goes from 0, 0 to 0 on the X, 730 on the Y, etc., etc. It also shows us our depth. Now these green circles, they are layer screw, they're your construction holes. It also gives us our diameter. If the depth of our construction hole is the same depth as our border, then we know it's going through the part. We'll now choose a door. The blue circle, they're our handle holes, but the layer is pull. You might think it would be layer handle, it's not, it's layer pull. The red squiggles, they are the edge indicators. They do export with the layer name as text edge, but you don't have a strategy assigned to them in EzyNest. If you do, they will machine. It is the same with that text there. Our hinge cup, we can see it's hinge underscore 35 mil, depth is 13, diameter is 35. We can do the same thing with our hinge lug holes, which are, if we click off and then click back on, we can see it is hinge underscore 3 millimeters. For a reference, if you click on that corner and then click over there and click back, down here will actually show you from there to there is 417 across, 77.5 up, and by the diagonal is 424.1 millimeters. So you can very easily measure from point to point, not edge to edge, point to point. You can see it there. Now we'll talk about layers, specifically layers. So you can find these in the drawing properties. If you go to Machine General and then Tool. Here we have the layer button. We briefly covered this last week. We can see that we can alter the layers by default. Yours will probably be ticked as standard. If we say want to change our border layer and we call it border -2, go tab, save. We'll go yes, we'll save changes, apply, okay, okay. If we click on our red line again, which is our border, we can see the layer has changed to border -2. So that's what that layer will export to in EzyNest. I'll change that back to border, tab, save changes. We go yes, apply, okay. So each layer in CabMaster has a strategy assigned to it in EzyNest, or it can have a strategy assigned to it in EzyNest. It doesn't have to. For example, TextEdge, you don't want a strategy assigned. To break it down, CabMaster sends layers to EzyNest. EzyNest assigns the toolpaths or strategies to those layers and produces G-code that the CNC reads. If you ever have an issue where something is showing in CabMaster but not machining, it's nearly always because the layer has no strategy. So we'll talk about tools. Border, being the outside edge of the part, will usually have a 9.5 or a 10mm compression cutter assigned in that strategy. Whatever the diameter of the actual tool is, here we make it 0.1 mm larger. We do the same for cutout. We do not do the same for cut. The reason we do this for border and cutout is to ensure that any notches made in CabMaster are wider than the diameter of the tool. EzyNest will more often than not decide that a 9.5mm tool cannot fit in a 9.5mm gap. So if we tell CabMaster that the tool is 9.6mm, it will make a 9.6mm gap, and EzyNest will put its 9.5mm tool in CabMaster's 9.6mm gap. An excellent example of this is the notch for shadow rails. It ends. We can see that if we go to cabinet 2, choose our end left, and zoom in. So if the tool in EzyNest and that border diameter in CabMaster are the same value, the tool would come across, come down, across, and then back down. So the reason we make it 0.1 mm larger is when that tool comes in, it will go down, go back into that notch, then go out and down. Now, cut needs to stay exactly the same as the tool diameter. And the reason for that is it's used to calculate the overall heights of draw banks when forced as full door. We look at this draw bank, we'll go down bottom right corner, machining, and we'll choose draw bank. We can see that here. If we click from there to there, we can see our height there is 367.3, but our actual draw is 362.5. So what it's doing is it's going 362.5 plus the diameter of our tool plus 362.5. We'll now look at the boring diameters, or the drills. Whatever you set the diameters to here will output to EzyNest, but it doesn't mean that they'll use those drills. Again, it comes down to the layer having what strategy assigned or what strategy is assigned to that layer in EzyNest. Here we have screw 5mm. If I have a strategy in EzyNest that uses the 3mm drill, it's going to machine as 3mm regardless of what that says. If I change the diameter here to 3mm, tab, apply, and OK, we can go look at one of our cabinets. There it is there. Layer screw, diameter is 3mm. Now it is worth noting that for draw runners, there are draw tables that control the positions of your drilling and your machining, but the actual diameter for your draw runners comes from here. Hinge plates works a little bit differently. If you're using a hinge table that is, say, Blum screw, Blum inserter, any of these, it will ignore what it says here. But if you're using a hardware pack or have a hardware pack set up, for example, if we change this to pack 1, apply, we'll go back to our, we're going machine general, back to tool, and we'll set hinge plate. Let's go something ridiculous. Let's go 20mm. Tab, and we'll set our hinge lug as 2mm. Tab, apply, and OK. We'll click on one of our door cabinets. Start by looking at the end left. There's our 20mm hinge plates. We'll look at our door. There's our 2mm hinge lug. Room properties. So I'll go back to hardware and I will change it back to using the Blum screw, apply. Okay. Quickly back to here. Look at our end left. And you see they've gone back to a 3mm. And they've gone back to 3mm. You'll even see that the layer has changed. So now we'll talk about penetration depths. We go back to Machine General, Tool 2. These are our penetration depths here. So this is how much deeper the tool will cut than the thickness of the material. In this case, 16mm material will show as 16.2mm cut in EzyNest. It just means the cutter is going to go 0.2mm into the spoil board. Parts under certain sizes, you can then have that depth reduced. Bear in mind, it's reduced from that value, not from 0. It explains all that just there anyway. So now we're going to talk about outputs. So we'll go to Machine General, Constant 2. We have flatbed output path. That's just saying where it's going. We can see that there. That is that folder. I've already output the machining for this. What I'll do is delete that so that when we output it again, we can see that it's there. I'll open that up for later. You can also set alternative output paths for parts that are under a certain size or over a certain size. That way, if your machine is limited to a 2.4 meter bed, anything that's say 2700, however you want to do it, will be outputted separately. If you're running 2 CNCs, a smaller one and a larger one, you can send all the files for your larger parts to your larger CNC and small parts to your smaller CNC. Split up production, however you want to do it. Material name, very basically, a very basic explanation is material name is the actual name of the material, not the difficult to explain. Maybe it's easier if we look at Materials Advanced. So remember that material name, manager, we'll click on manage. That is your material name. Raw material will export as that. So I guess you could say it will split up panels and doors. Okay, now we'll quickly go over pre-milling because that is also very important for day-to-day. And that is in constant, just here. So you can set pre-milling to allow for the thickness of the edge tape, or you can have it set to a predetermined value. Here I've got 1 mil. If your pre-milling set to 1 mil, then a 600 by 600 door that's edged all around will cut on the CNC as 600 by 600. Of course, if that pre-milling thickness is set at 0, then your 600 door would cut at 598 by 598. So that is the basic premise of how layers work and export. Well, not so much export, but how they work in EzyNest and how they're set up to go to EzyNest. So we'll export this job and then we'll open it in EzyNest and cover that. There's 3 key ways to export machining. The first one is F8 on the keyboard. You'll get a message there saying what's created. It has created 21 DXFs, which are 16mm carcass white, 4 DXFs, which are 18mm new antique white. So it should have one of those lines for each material. If I had a panel in this drawing and I had selected material name instead of raw material, we would have 1 DXF that is 18mm new antique white panel. I'll click OK. The second method of exporting machining is File, Export, Export Machining. Now, if you've already exported the job, it's going to come up with this saying, do you want to overwrite the existing? We'll go yes to all. There's that pop-up again. The third method is to go to View, then Machining, then Export Machining. Yes to all. There's the pop-up again. You can generate nests within CabMaster. This needs to be set up by support, and you only do it when you've got your ATPs and strategies all set up correctly in EzyNest because it uses EzyNest. You don't have the control to check things or change things like you do in EzyNest. So everything has to be absolutely perfect before you can trust that what you generate here is going to run fine on your machine. If we go to File Explorer, that's the name of our job, Drawing 2. There's our carcass white. There's our new antique white. We'll click Generate Nest. There's our nest there. So as you can see, you can't actually do anything with these like you can in EzyNest, but we can see those if we go to Machining Out, Drawing 2, there's our outputs. I'm going to delete that because we want to see it in EzyNest, or be exported from EzyNest ready to go to the CNC. Go back to CabMaster, back to View, back to Plan. Okay, so now I'm going to open EzyNest. Here's EzyNest 23. Normally when you start it, you won't have this window here, but you can find that by going help about you want to get rid of it, you just click on it. So we're going to load an ATP with this button up here. And then we're going to load an ATP file. So if you're doing 16 mil HMR, you've got one there, one for MDF, different materials, different thicknesses, different sheet sizes. We're not going to cover any of that today. We just want to make sure we're selecting the right one. Then we'll go to parts. We'll go add list file. We will navigate to our machining folder, to our drawing output, to the material. There's our output. We can see our parts. We can see our dimensions, the thickness of the material, the name of it, the unit number, the quantity. You can turn them on and off. If we go to map, this is a list of the layers and assigned strategies that are saved in the ATP, not necessarily what has been exported from CabMaster. There may be more here than what has come out from that job from CabMaster. There may be less here. Straight away, we can see that border is using, if I go to that one, a 10 mil compression cutter, 3 wing, 16 deep, 2 pass. It explains everything that it is doing. But if you remember back to our drawing properties, we know that our cutter was actually 9.6. So we already know that that shadow rail notch is not going to cut. Now these strategies are specific to the tools that are in the machine. So it's more likely that EzyNest is correct and CabMaster is incorrect in this specific scenario. Because if you actually had a 9.5 mil tool set in the machine and you had a strategy using 9.5 tool, then you wouldn't be getting any borders cut on any other jobs. So from here, I'm going to skip to output. I'm going to untick everything there so it doesn't produce any files. Click process parts. There we go. We can see the notch isn't cutting. We can see our 3mm drill is going 16 too deep. We can also see that our 5mm runner holes are not machining. So taking what we've covered, we're going to go back to CabMaster. I'm going to go to Home and then Drawing Properties, back to Mac General and Tool, and I'm going to change these to suit a 10mm tool. So I've got 10.1, tab, 10.1, tab, 10, tab. Our screw layer, we actually want that to be, say, 5mm, tab, instead of 3. And now we'll go apply, and we'll go and look at our draw unit, have a look at our end, click on the runner hole, and we'll see that the layer is runner and it's using a 5mm drill. Knowing that, we can re-export our machining again, F8 on the keyboard, yes to all. It's recreated the DXFs. Back to EzyNest. I'm going to close that one, go no. Automatic toolpath, parts, clear this list and add it in again. As you can see, the time is 1:27, so we know that that is the latest output. I'm going to go to map, and we see that runner doesn't have a strategy assigned. So we're going to select that, and we're going to go find 5mm drill, 13 deep. I'm going to save the ATP. Also see that the depth is set to 20mm. I am going to change that to 13mm because we have 13 there. It's good practice to include the save depth in the strategy name. Here it's 13 deep, so we'll change the design depth to 13 to match, and we will save the ATP. It's always good practice to save your ATP as you're going for changes that you know are going to be permanent. If you're just testing things and not producing output or not producing code for the machine, you don't have to save the ATP if you just want to test and then go back to how it was prior. Now I changed the screw layer to use a 5mm drill, which means I need to change it here to 5mm drill. So we'll do the same thing. Design depth's already 13. Save ATP. Before we have to process the parts again, you would reload your parts. And then we'll go to the output tab. We'll just quickly untick everything, process parts. If we go down here, we can see the notch is now machining. We can see that we now have a 5mm hole for our screws, and that we can see our runner holes are machining. And if we right click, edit toolpath, we can see that it's going 13 deep. If we left the design depth for that strategy and that layer as 20mm, I've already tested this, it would have come out at 6mm. But that doesn't mean it's always going to be less. It could go the other way and end up as 27mm, and then you're going straight through your sheet into your spoil board. Depending on the thickness of your spoil board, you're going into the vacuum bed. So that is very important. If you ever add a layer, add a strategy, leave the design depth to 0 if in doubt, but if you know what the design depth needs to be, you can put it in. So we now have a working ATP that will machine as we want it to. So we can produce our machining. We go to the output. We don't need to touch anything again because we've saved our ATP. I'll double check we've saved our ATP. Click save again just in case. We'll go to output. We'll give it a name and we'll call it nesting webinar. We'll process parts. There we can see our sheets. We go to File Explorer, Machining Out. Because it's not creating a subfolder, it's right there in Machining Out, and there are our files. So I'll minimize that back down. So now that that ATP is working, you could go back to EzyNest and nest, could go back to CabMaster, sorry, and nest directly within CabMaster, knowing that what you've done here will come out from CabMaster as well. But let's say we want to put in an LED strip rebate to the back of one of our cabinets. I'm going to go back to CabMaster. Here's one I've prepared earlier. Cabinet machining, custom, back. Tick on LED strip rebate, apply and OK. We zoom in on that a bit. If we click on it, we can see our dimensions. We can see our depth is 18 mil. The layer is LED rebate. We click between. We can see that is 18 mil from there to there. And from there to there is 5 mil across, 50 up. So we know it's 50 down to that edge, and it extends out 5 mil. The reason for that is the radius of the tool, so that you end up with a square corner there and not a radius there where the tool stops. So I'm going to close that, re-nest with F8 again, yes to all, click OK, back to EzyNest, close that down, we can close that one too. ATP, we're going to re-import our parts, so clear, add list file, double click on it, and I'm going to unselect everything except for cabinet number 3 back, because that is the part we added the LED rebate to, just like that. I'm going to go to output, untick, process parts. Where's our rebate? We know it's larger than the diameter of the tool, so it should cut. So we're going to go back to the ATP, go to map, and we're going to look for our layer. So we know in CabMaster that the rebate was, LED rebate was the layer. So if we go back to EzyNest, we'll click Use Parts, and it will show up down the bottom of our list. Straight away, I'm going to save this so that I don't have to keep doing it as I'm testing different strategies on that layer. Now I am going to use a 10 comp, 3 wing, 16 deep, 1 pass female. That's the one I want there. The reason for that is it's the same tool as border, so I know it's not going to have to do a tool change. I know it's going to run because that tool's already in the machine. I know the design depth. I know it's doing 1 pass, and being an offset female, it means it's internal, so it will cut inside the line. So I can go ahead and set that as 16, or if in doubt, leave it as 0. So I'll go back to, after saving ATP file, go to output, going to untick those, process parts. There's our LED rebate. We right click on the toolpath, edit this toolpath. We can see it's 8 mil. So that covers 99% of your daily EzyNest usage. There are many things which I haven't discussed today. That is because they're more advanced features, more specific to setting up CabMaster and EzyNest for the first time. I'm not going to go into creating strategies, editing ATPs, anything like that. Generally, once your machine has been linked, you have working strategies and ATPs. You really don't need to change anything other than looking for your layers, adding in the occasional layer, using a strategy that you know works because it's applied to something else, which is what we've done here. Do we have any questions? Can you nest different material thicknesses at once to save time? In theory, you could if you're nesting, say, 16.3 and 16.5 mil whiteboard. Certainly. If we click on here, the trouble is that in EzyNest 23, because it has different layer names, it will put them onto different nests. As long as they've got the same raw material name, then theoretically they're going to go into the exact same spot, but then your material is different. That is a very good question. Even though it saves time, I don't probably recommend it, honestly. If you wanted to produce the machining for your doors and your carcass at the same time, you do them separately as well. Everything is about control and making sure that you've done everything right before you send it to the machine. Nesting multiple material thicknesses at once or multiple materials at once, it takes away that control. It introduces an element of risk, which you probably don't want. How do you save nest patterns? Good question. If I close that, save, nest pattern, just like that. That is in 16 carcass white. We'll go save. Close that down. We'll go no. Open. There's my nest pattern. Now, just because you have that doesn't mean it will automatically produce new code. You would have to go through G1. I'm not going to go through this now because this is, again, very much tied into setting up your ATPs correctly. Okay, and I think that just about covers it. Thank you, everyone, for joining today and coming along for this ride of exporting and nesting. I hope to see you in the next webinar.